All right, Algebra 2, here are here's a second part of our videos for section 4.6, continuing this conversation about imaginary complex numbers, right? Or imaginary slash or comma complex numbers, not at the same time, right? So, and then let's go ahead and talk about that distinction, right? So a complex number, we talked about an imaginary number up above, our imaginary unit is I. We can have 4i, we can have I times the square root of 3, etc. But a complex number, when we write it in standard form, is the number a plus bi, where a and b are real number coefficients. Okay, so that means that a and b, they're pretty much any number. They can be like 1, 1.5, 3.5, square root of 7, whatever, right? It can be, a and b can be pretty much anything in the real number system. Now, a is the real part, and bi is the imaginary part, because a does not have an imaginary number attached to it, but b does. B has the I attached to it, so it's an imaginary number, okay? So then now complex numbers, every time we make a number system, we have rules for adding, subtracting, multiplying, and dividing. That way we can work with these numbers, okay? So let's see how addition and subtraction first work in this new number system, okay? So when we add and subtract complex numbers, we're pretty much just adding and subtracting like terms. Okay, so let's see what we mean by that with this first example. We have 8 minus I plus 5 plus 4i. So this is a complex number, and this is a complex number, right? Notice that we have a plus bi, our a is 8, and our b is -1 for this first complex number. And then for the second, our a is 5, and then our b is 4. Okay, so what do I mean by like terms? Well, kind of like when you're adding together polynomials, like you can treat I as if it were X, as if it were some kind of variable, even though it's not, right? I is its own thing, it doesn't change. But pretty much, you just combine like terms. We take our 8 and you add it with 5. So we'll just do that separately. 8 plus 5 plus, then we have -I plus 4i. So -I plus 4i. So 8 plus 5, we know that's 13. -I plus 4i, that's going to be 3i, right? Works exactly like if you were adding variables together. Like if that was -x plus 4x, that would be positive 3x. And so here's our answer, all right? Now let's try part B. Same kind of idea, now we're subtracting, right? So 7 minus 3, and then -6i minus -6i. So plus -6i minus -6i. All right, so 7 minus 3, we know that's 4, plus whatever we get from this, -6i minus -6i. Well, this is just plus. -6i plus 6i, that's 0i. So then our answer to this is just 4. Okay, so from this, we got just a real number. Now, this is still a complex number because what that means is that our b was just 0, like this, like we have here. It's 4 plus 0i. Still a complex number, okay? It's just a complex number with no imaginary part. One more example just to make sure you have the hang of this. So you have -4 plus -1 plus I minus -5 minus 9i. Let's do it, two at a time. Let's do this first one. -4 plus this complex number has no imaginary part, so we're just going to combine the -4 and the -1. We have -4 plus -1. We can probably just do that in our heads, right? -4 plus -1, that's -5. So -5 plus I minus -5 minus 9i. Okay. -5 minus -5. And then plus I minus -I. -9i. I don't know if I said the 9. So -5 plus 5, that's just 0. And then I minus 9i, sorry, I minus negative 9i, that's I plus 9i, which is plus 10i. So then our answer is just 10i. Still a complex number, but now this is also just imaginary. There's no real part, okay? So addition kind of works like we're used to seeing it with, what the number systems we've been working so far with, real numbers, okay? And you're gonna find that it's kind of the similar idea for multiplication. Let's go to multiply some complex numbers together. All right, so let's start with this first one. When I multiply, notice that it kind of looks like as if I were distributing, with polynomials. You can treat this as like a 4x, negative 6 plus x. In that case, I would distribute, right? So let's do that. So 4i times negative 6, that's negative 24i. And then 4i times I, that's going to be plus 4i squared. Now we're not done here because we have to write it as a complex number in standard form. In my standard form, I need to have a real number and an imaginary number. Or I can have just one or the other, right? But what I don't want is this I squared, okay? So I'm not done yet. We talked about in the first video, I squared is just negative 1. So then this becomes negative 24i plus 4 times negative 1. So that becomes negative 4. And if we want to write it in standard form, our real number goes first. Negative 4 minus 24i. Okay, it's not imperative that you write it in that order, but it's nice to follow our standard form. Okay, so that was just, with an imaginary number times the full complex number. Now let's do two full complex numbers times each other. Same way that you would do it with regular expressions involving a variable, right? FOIL or distribution, whatever you learned. 9 times 4, that's 36. 9 times 5i, that's plus 45i. Negative 2i times 4, that's minus 8i. Negative 2i times 5i, that's going to be minus 10i squared. Okay. So then now let's just, combine our like terms. We have 36, 45i minus 8i. That's going to be, 37i. Sorry, I almost said the completely wrong answer. 37i, right? And then again, this I squared, that's going to be negative 1. So this is going to be negative 10 times negative 1, which is going to make it positive 10. So 36 plus 37, I plus 10. And then we have two more like terms to combine, 36 and 10. So this is actually going to be 46 plus 37, I. And that is our complex number. Okay, not too terrible. It's definitely not something you haven't done before, but now the difference is that we get these i's. So like I squared, that doesn't stay I squared, that becomes negative 1. All right, and we can do the same thing with any power of I. It'll become something a lot simpler. All right, one more example of multiplication. Notice here, this looks similar to what we did in our factoring sections, 4.3 and 4.4. If you notice, this looks like A plus B, A minus B. And that's a special pattern. And when we have that, let's try to use it to our advantage so we do less work, right? Remember, we're lazy. This is going to give us A squared minus B squared. It's our difference of squares. So then I can just say, well, A is 8, B is 3i. So then I can write it as so. I can write 8 squared minus 3i squared in parentheses, right? We're squaring that entire thing. So then we get 64 minus, what's our 3i squared? That's going to be 9, 3 squared, I squared. But then again, remember, I can change this I squared to a negative 1. So this becomes 64 minus 9 times negative 1, which is 64 plus 9. When we add that, we get 73. So isn't it weird that this whole thing, like when we multiply this out, we get just one real number, right? We take two numbers that have imaginary pieces. So they're in the complex plane. They're in a completely different number system. We multiplied them and we just got something that's a real number, something that can live in a different system, okay? So just kind of be aware of that. You can definitely get just a real number from these. Same thing from above. We got cases where we added things and we just got a real number, or we just got an imaginary number. Okay, we did 3 operations. We have 1 left, division. It's the most complicated one, but it's not hard at all. In fact, it'll look pretty familiar, the process we're going to do. When we divide by a complex number, we need to use the complex conjugate. And this is similar to the conjugate we talked about when we rationalize the denominator, right? If I wanted to rationalize, say like, you know, it was 2 over 1 minus square root of 2, then I multiply top and bottom by 1 plus rad 2, 1 plus rad 2. It's very much the same idea here. Okay, so let's see how that works. First example, 1 plus 2i over 3i. Well, if you remember, if it was 2 over rad 3, the way we rationalized this was just multiplying by rad 3 over rad 3. Okay, we've done that before already. Now, let's say if there was like a 5 in front of this rad 3. I wouldn't necessarily multiply top and bottom by 5 rad 3 over 5 rad 3, because then I'm going to simplify those 5s out anyway. So that'll just create more work for us if we include the 5. So we could actually here still just do, oh, sorry, that was a really tall rad. We could still do rad 3 over rad 3. And it's going to be the same case here. If I'm going to divide this I in, what I need to do is multiply top and bottom. Let me do it in a different color. Top and bottom by I. Okay, whenever you see just a standalone I or an I with a coefficient, we're just going to do top and bottom by I. And we'll see why that's going to work. Let's go ahead and try that. In the numerator, I'm distributing the I. So I plus 2I squared over 3I times I. Remember, we're just multiplying across. 3I squared. Okay, so let's simplify. I get I plus 2 times I squared. That's going to be 2 times negative 1, right? Over, same idea, 3 times I squared, that's 3 times negative 1. Okay, so I plus 2 times negative 1, that's going to be I minus 2 over negative 3. And then just so we don't have a negative in the denominator, remember I can move this negative to either out in front, or I can strategically do it to the numerator. So now I have, distribute that negative 1, I get 2 minus I over positive 3, right? And we're allowed to do that because, 1 over negative 1 is the same thing as negative 1 over 1. Both of those are just going to give us negative 1, right? So then here's our answer. And if I want to write it, simplify all the way down so I can have it in standard form, then I just divide each of these by 3. So I get 2/3 minus 1/3 I. And that is my complete standard form. This is my standard form. Okay. One more. Here's where we're going to actually use our conjugate. Okay. So kind of like we did with our rationalizing the denominator, we're going to multiply by 1 plus 4i. Remember, we're changing the operation in the middle. 1 plus 4i. So now it's going to get a little ugly, but let's just bear with it, right? Numerator, we're going to have to distribute. So I get 7 plus 28i plus 5i plus 20i squared. So that's our numerator. Now our denominator, we can use those special patterns to cheat a little bit, right? This is a minus b times a plus b. So I get a squared minus b squared to make my life a little easier and a little faster. So in the numerator, I can do 7 plus 28 plus 5, that's 33i. 20 times I squared, we've already seen that's going to be 20 times negative 1, so we can just write this as minus 20. Over 1, because 1 squared is 1, minus 16i squared. The I squared is a negative 1, so this is just going to be plus 16. Okay, I skipped a few steps there. So hopefully you're okay with kind of each of the things that happened, right? This 20 I squared became negative 20 because this is 20, this is 20 times negative 1 because I squared is negative 1. And then same thing with the 4I squared. That became 16I squared, which is negative 16. So that's why it's plus 16 now. Combine like terms one last time. We get 7 minus 20, that's negative 13 plus 33I over 17. And if we want to write it in full standard form, this is going to be negative 13 over 17 plus 3 over 17I. Okay, just dividing that 17 through to each term. All right, so that was section 4.6, complex numbers, right? If you're at all confused, don't stress too much. We're working with a completely new number system. You probably never worked with this before, right? Especially as an Algebra 2 student. So take your time. If you need to look up some other videos, look up some videos on Khan Academy or Patrick JMT. Just look up some complex numbers or imaginary number stuff to understand it a little bit more if you're still a little confused, okay? Otherwise, we're also going to talk about it in class next time I see you, okay? Have an awesome day. See you in the next one.